expression, and it's of no use to us. We, for whatever reason necessary, may need to change the base. You get given this formula. Okay, so if you'll notice here, I've been given an initial expression in base B, and I want to change it to the now base C. Okay, and the A and the B are corresponding to these A's and B's. Okay, so I'm hoping it's pretty straightforward. It's just a matching game. So if I was asked to evaluate this, I could do that by changing the base of it. And if this was on the calculator paper, you would be able to, well, I'm secretly calculators now, you can just chuck that in, okay? But before, you would have to change it to base 10. So if I were to change this to log base 10, what would I do? So I want to change it to log base 10. It's currently log base 2. So we're looking at this thing here. So this is our current situation. So what's my value of A? My value of A is 7 and my value of B is 2. Okay? So if I change it to log base 10, that means that C is going to be 10. Look at that. Yeah. So I would write log of what? I don't need to write 10. So log is what's A? A is on the top. Over 2. That's it. Okay, it's not anything more challenging than that. So you can then use your calculators and do log 7 divided by log 2. No, it's not log 7 over 2. It's log 7 divided by log 2. And we would find the value for it. So can everyone tell me what that is? Alright, so we've got 2.81 to 360. Because we know that's correct. Yeah. Use to change the base formula to evaluate log for 9 to 3 significant figures. So this time our A is 9 and our B is 4. So we're changing it to base, it doesn't say which base, again, probably log base 10. So what would I write? Log 9 over log 4. Is it cheap? Yes. Okay, so we've got 1.58. Log base x of 3 equals A, log base x of 6 equals B. Find log base 3 of 6 in terms of A and B. So here our value of A, if I use A and B, do you know I'm talking about the original A and B from the formula? Okay, so formula A is what in this question? So look at 3. So it's 6, yeah. So if we look back up, remember it says log B of A in the formula, yes? So our value of A is 6. And the formula B is 3. What base are we going to change it to? Nice. You'll see that X is the useful one now. Yeah. Okay. So this would now become log base X of what? 6 over log base X of 3. Okay, so we've now changed our base, so it's in the correct base, but they want it in terms of A and B, and obviously now they're referring to this A and this B. So we've now got, which one's on the top? And A is on the bottom. Lots of A's and B's, all confusing. But this is the kind of situation you might have in the exam. So is everyone happy with that? Yeah. Yeah? Yeah? I may as well just go through this as well, just so we can get good and bring on some of the work. So solving exponential equations, you may or may not have done this before. I think you may have looked at it when you were did CIE. So if your unknown is as a power, how we would solve that is we would take logs of both sides. Okay? Now you can take logs of any base, both sides, as long as it's the same one for both. You can take natural logs. Oh, yes, we can talk about that. Yes. No, we haven't talked about it yet.
No, there was like one.
Hold fire. We're going to do another sheet first. Alright, so natural logs. Natural logs. These are logs with a base of e. Okay, so remember we talked about e briefly the other day. So e is that special number, 2.71, blah. We don't really worry about what else it is. So it's just a special number, and it's so if you have log base e, then it is normally written as ln. Okay, so if you see ever ln4, that's an L, not an I. So if you see ln4, it means log base e of 4. Okay, that's the only thing that you need to know about natural logs. It's just it has a different base. So where we see log base, if we just see log 4, that would be base 10 of 4. If we see ln4, it means log base e. As I've said here, they're treated in the same way as any other log. You just need to remember that the base is e. Now, it's helpful in some situations because if we have natural log of e, oh, we could have a log. That's something like that. Oh. Alright, if you ever have ln e anywhere, we know that that's going to equal 1 because ln e, oh, you're kidding. Because I'm going to have to. Oh my God. So, if you have ln e, oh no, I'm from over it. That's going to equal 1 because we know this means log base e of e. And we know if it's the base, same as the value we're taking the log of, we know that the score is going to be 1. So, a couple of questions. Log as a single, write as a simple logarithm or integer. So when we're adding log statements, what do we do? Multiply. So this is ln of 5 multiplied by 8. I'm doing it in 2 steps. So I've got ln of 40. And then if I'm subtracting logs, right, so it was ln of 40 over 2 is ln 20. That's tricky. That's tricky. Alright, okay, now this one here, it's handy for other questions as well. I don't know if you've spotted any of these up until this point. So here I've got 2 plus log, natural log 4. And I need to join them together or write it as a single log. Any suggestions what I might do?
Would you still put up
One of you.
because you know how like if it's an addition, like when it comes to the log, you multiply it.
But remember, this isn't a log
Yeah,
minus.
so I'm saying, would you like how put that as a power?
As a power? I'm not quite as power, but I'm going to write it as a log.
Would you log here
Oh my goodness. Alright, so I think what you said was correct. So what did you say you want to do? Oh, yeah, sorry.
log here, log here.
Oh, that equals 1. Okay, you've got the right idea. Log EV, log EV. But secretly what we could do is just, oh, you're Alright, so instead of 2, I'm going to write 2. Oh, I don't know what to do. Alright, so instead of just 2 here, what I can do is I can change this to 2 ln e. And we can do that because we know that ln e is equivalent to 1. So I haven't changed it. You want to do that?
Yeah.
Yes? and it's two of them, so we've just got two lots of L and E. Because remember, we can do anything to mathematical statements as long as we don't change the value of it. So if you're multiplying something by 1, that's not going to change the value of it. Alright, so it's looking a bit better now, but this 2 isn't helpful when we're trying to join log statements. So where's this 2 going to go when we're joining log statements? To the power. Yeah, so this is now going to be written as ln e squared. Happy with that?
Yeah.
Excellent.
Yeah.
Now we've got two log statements adding together, so we multiply. We would normally write the 4 at the front, so we would write ln 4e squared.
I'm got that.
Okay, so that's now written as a single logarithm. So the key thing with this one particular is this whole 2 business. I don't think we've covered any of those. I've also thought it might be handy to do that for this one. Alright, so everything else about it is exactly the same though as any other treatment of any log.